22. If the length of a copper wire has a certain resistance R, then on doubling its length, the specific resistance becomes. Answer is well known for you. Specific resistance, another name resistivity. It remains constant. But remains constant does not change. How is it possible? Why? How can you say that it is remaining constant? If the length of the copper wire has a certain resistance R, length of the copper wire has a certain resistance R. On doubling its length becomes doubled, 2L ஆக்குன. What happens to the resistance கேட்டதா பரவாயில்ல, அவங்க கேட்கறதே what happens to the specific resistance. Length L இருக்கும்போது resistance R இருந்தா அப்போ specific resistance is rho. When the length becomes double, what happens to the resistance? What happens to the resistance அப்படின்னா length double ஆகும், resistance double ஆகும். Yes, let us go from the basic equation, relation with the current and drift velocity from Ohm's law. I is equal to NAVDE. The relationship between the current and drift velocity. The flow of current in a metallic conductor is only due to the drift velocity. The current flows only due to the drift velocity. We know the drift velocity is given by obtained by the equation. Yes, E by m into tau. Tau is the time interval between the two collisions. I is equal to NA, where VD is equal to EE by m into tau. Already over E. Drift velocity equation. அதை பேஸ் பண்ணி தான் மொபிலிட்டியை டிஃபைன் பண்ணுவோம். Yes, in this equation, I is equal to N A E into E square tau by m into capital letter E, electric field, nothing but potential gradient. Potential by distance. What is the potential difference? V. Distance of the length of the conductor is L. L is the length of the conductor. That is the distance B. So, this is potential gradient. Potential by distance called potential gradient, nothing but electric field. E ki badala. So, in this equation, I is equal to as number of electrons per unit volume. N is number of electrons per unit volume. Say number density, electron density, charge density, any name. It is a constant for one material. Copper அப்படினா அது ஒரு வேல்யூ தான் இருக்க முடியும். அது திக் வயரோ தின் வயரோ, திக் ராடோ தின் ராடோ, அது ஸ்பியரோ மெட்டல் பிளேட்டோ, காப்பர்னு சொன்னால் இது ஸ்மால் இஸ் சேம் ஒன் வேல்யூ. நம்பர் ஆஃப் எலக்ட்ரான்ஸ் பர் யூனிட் வால்யூம். அலுமினியத்துக்கு இன்னொரு வேல்யூ இருக்கும், அயனுக்கு இன்னொரு வேல்யூ இருக்கும். ஒரு மெட்டீரியலுக்கு ஒரு வேல்யூ தான். And this N is constant. For a given conductor area, cross-sectional area, thickness of the wire is same, constant for a given wire. A charge of the electron, any electron, the same charge, 1.6 × -19. And at a constant temperature, room temperature, the relaxation time, that is called time interval between the two collisions, constant. It depends on temperature. Mass of the electron always constant. For a given conductor, length is constant. This constant is 1/r into V. This is George Simon Ohm proposed பண்ணுற law. That is, இது directly proportional, I is proportional to V ன்னு சொல்லிட்டு, at a constant temperature, the steady current flowing through a conductor is directly proportional to the potential difference between the two ends of the conductor. Ohm's law. Right, நமக்கு இங்கே Ohm's law முக்கியம் இல்லை. 1/r, 1/rக்கு பதிலாக இது வச்சுருக்காங்க. ஸோ R is equal, what is the value? தலையிடா போடுங்க, mL by NAE square into tau. So, இதில் mass of the electron always constant. காப்பரில் இருக்கிறது எலக்ட்ரானுக்கு மாசும், அலுமினியத்தில் இருக்கிற எலக்ட்ரான் மாசும் சேம் தான், always, any material. And for a given material, this number density or electron density is constant, number of electrons per unit volume. Charge of the electron is constant. And at a given temperature, room temperature, particular temperature, tau is constant. So, R is proportional to L by A. R is proportional to L by A. It is R is equal to upon rho into L by A. இப்போ ரோவுக்கு பதிலாக அப்போ ஆர் இஸ் டைரக்ட்லி ப்ரொபோர்ஷனல் டு எல். ஸோ அப்போ நம்ம கொஷினில் லென்த்து எல் இருந்தால் ரெசிஸ்டன்ஸ் ஆருக்கு டபுளிங் த லென்த் வாட் இஸ் த ரெசிஸ்டன்ஸ் கேட்டால் சிம்பிளாக சொல்லிட்டு போயிடலாம், டபுள் ஆகும், டைரக்ட்லி ப்ரொபோர்ஷனல். லென்த்து டபுள் ஆனால் ரெசிஸ்டன்ஸ் டபுள் ஆகும், 2R, ஆர் பிகம்ஸ் 2R. ஆனால் அவங்க ரெசிஸ்டன்ஸ் கேட்கல, ஏமாத்துறதுக்காகவே ஸ்பெசிஃபிக் ரெசிஸ்டன்ஸ் கேட்டிருக்காங்க, ரோ கேட்டிருக்காங்க. அப்போ இங்கே கான்ஸ்டன்ட் ரோ வருதுன்னு இந்த ஈக்குவேஷனில் L/A விட்டுட்டு மீதி எல்லாத்தையும் ஈக்குவலன்ட் ரோ போடலாம் இல்லையா? எஸ். ஸோ இங்கே என்ன இருக்கணும், L/A விட்டுட்டு மீதி என்ன இருக்கு பாரு, M/N E² into tau. Now conclusion வந்துட்டோம். The specific resistance depends on mass of the electron. No, mass of the electron is always constant. Number density or electron density, number of electrons per unit volume, a constant for one material. காப்பர்னு சொன்னால் அதுக்கு ஒரு மெட்டீரியலுக்கு ஒரு எண் தான் இருக்கும். Electron, charge of the electron always constant. At a given temperature, at one particular temperature, tau is constant. அப்போது specific resistance is constant for one material. ஒரு வயரோட லென்த்தை டபுள் ஆக்குனா ஸ்பெசிஃபிக் ரெசிஸ்டன்ஸ் ஒன்றும் ஆகாது. ஏன் ஆகாதுன்னா இந்த ஈக்குவேஷனில் எல் வரல. எல் மேலேயோ கீழே இருந்தால் எனக்கு ஸ்பெசிஃபிக் ரெசிஸ்டன்ஸ் இன்க்ரீஸ் ஆகுன்னு சொல்லுவேன், டிக்ரீஸ் ஆகுன்னு சொல்லுவேன். ஸோ ஸ்பெசிஃபிக் ரெசிஸ்டன்ஸ் ஆர் another name electrical resistivity is independent of the length and independent of the cross sectional area. ஏ வரல, thickness வரல, ரேடியஸ் வரல, டயாமீட்டர் வரல. என்ன வந்திருக்குதுன்னு கேட்டால் என்னை கேட்டு சொல்லலாம், ரெண்டு ஃபேக்டர் ஒன்று சொல்லுவேன். ஒன்று மெட்டீரியல் டு மெட்டீரியல் சேஞ்ச் ஆகலாம், அது மெட்டீரியலோடு கிடையாது. ஒரு மெட்டீரியல் காப்பர் வயர் எடுத்துட்டோம்னா, காப்பர்னு ஒரு மெட்டீரியல் எடுத்துட்டோம்னா அது தின் வயரோ திக் வயரோ ஷார்ட் வயரோ லாங் வயரோ N இஸ் கான்ஸ்டன்ட். 4 வயர்ஸும் ஒரு ரூம் டெம்பரேச்சர் வச்சுருக்கேன், டவ் இஸ் கான்ஸ்டன்ட். 4 வயர்ஸ்லேயும் மாஸ் ஆஃப் த எலக்ட்ரான் சேம், 4 வயர்ஸில் இருக்க சார்ஜ் ஆஃப் த எலக்ட்ரான் சேம். அப்போ எல்லாமே சேம் சேம் சொன்னால் ரோ இஸ் சேம். அப்போ ஷார்ட் வயர், லாங் வயர், தின் வயர், திக் வயர், எந்த வயராக சரி ஒரு மெட்டீரியலாக ஒரு ரோ தான். சம்மதர் மெட்டீரியல் அலுமினியமா இன்னொரு ரோ. ஸோ இங்கே ப்ராப்ளத்தில் அவங்க டபுளிங் த லென்த் வாட் வில் ஹேப்பன் டு தி ஸ்பெசிஃபிக் ரெசிஸ்டன்ஸ் கேட்டிருக்காங்க. லென்த் இண்டிபெண்ட் ஆஃப் லென்த்து, இண்டிபெண்ட் ஆஃப் த கிராஸ் செக்ஷன் ஏரியா வரல. தட்ஸ் வை ரோ இஸ் கான்ஸ்டன்ட். ஸோ ஆன்சர் ஃபார் திஸ் கொஸ்டின் இஸ் ரோ இஸ் கான்ஸ்டன்ட். ரோ டஸ் நாட் சேஞ்ச். ஸோ இந்த ப்ராப்ளத்தில் எல் ஒரு ஃபேக்டர் இல்லை. Answer for the problem, its specific resistance will be doubled. Length resistance கேட்டால் doubled, ஆனால் specific resistance கேட்டிருக்காங்க. ஸோ ruled out. will become 1/4, அப்படி ஒன்று கிராஸ் பண்ணவே இல்லை, ruled out. will become 4 times, அப்படி ஒன்று கிராஸ் பண்ணவே இல்லை, ruled out. will remain the same, அதுதான் சொல்லிட்டு இருந்தோம் எல்லாரும். will remain the same, does not change, it is a constant. So answer for this question number 22 is D, option D. உங்களுக்கு ஃபெமிலியர் கொஸ்டின் தெரியும், பட் ஒய்ங்கிறத ப்ரூவ் பண்ணுறதுக்கு தான் நான் இந்த எக்ஸ்ப்ளனேஷன் எடுத்துக்கிட்டேன். எஸ், லெட்ஸ் பாஸ் ஆன் டு த நெக்ஸ்ட். 23. A graph is drawn taking the potential difference across ends of the conductor along x-axis and current through the conductor along y-axis. The slope of the straight line gives. Here the problem is about the graph plotted between the potential difference and current. A graph is drawn taking potential difference across the ends of the conductor along x-axis and the current through the conductor along y-axis. Let me draw the graph. What is question number 23? X-axis, y-axis, the potential difference V, voltage along the potential difference is taken along the x-axis and the current through the conductor along the y-axis. Yes, of the two, this is independent variable, this is dependent variable. As voltage increase, current increase. voltage decrease, current decrease. So this is along the x-axis and current is along the y-axis. A straight line is obtained. Let this one be a straight line passing through the origin. Yes, as voltage increased, proportionately current also increased. That is linearly proportional. What we say, obeying Ohm's law. What we call this current as ohmic current. The current flowing in metals obeying Ohm's law is ohmic current. If we take the slope of the straight line, the slope is nothing but tan theta. So take a triangle. So what is tan theta in this triangle? Opposite side by adjacent side. Opposite side is current. Adjacent side is voltage or potential difference. So the slope of this graph gives nothing but I by V. Current by voltage is slope or 1 by slope. Reciprocal of the slope is V by I. Potential difference by current, voltage by current is called resistance. So if you take the slope for this straight line and the inverse of the slope gives the resistance, or in other words, if we inverse this resistance, that is by keeping the slope, and you can write this one as I by V instead is at 1 by V by I. 1 by slope is V by I. So slope is equal to I by V. I by V is 1 by V by I, and this is resistance. 1 by resistance. Reciprocal of resistance is called conductance. So in this question, the slope of straight line gives conductance, nothing but reciprocal of resistance. So the answer of the 4 options, reciprocal of resistance irukano or conductance irukano. So second option, conductance is there. Reciprocal of the slope nu ketirundanga இந்த questionல slope of the straight line கேக்கிறதுக்கு பதிலா reciprocal of the slope nu irundha, the answer is option A, that is resistance. Pass on to 24. When n resistors of equal resistance are connected in series and in parallel respectively, meaning first the n resistors are connected in series, then all these resistors are connected in parallel. First series and then in parallel. Then the ratio of their effective resistance, that is the effective resistance in series combination divided by effective resistance in parallel combination is question mark. When n resistors of equal resistance, say this is one resistor of resistance R, resistor of resistance R, resistor of resistance R, like this n resistors are connected in series. So what is the effective resistance in series combination? Yes, you know that formula, already I have used this one. It is R1 plus R2 plus R3 plus R4. So it is R plus R plus R plus R plus up to n resistors. If there are 2 resistors, 2R. If there are 3 resistors, 3R. If there are 5 resistors, 5R. If there are 10 resistors, 10R. N resistance irundha NR. So Rs is equal to NR. The same resistors now connected in parallel. Parallel combination. 2 resistors. If there are 3 resistors, here also you can put 3 resistors. The same resistors now connected in parallel, like this 3, 4, 5, 6, 7 n resistors. Now the formula for the effective resistance is 1 by Rp. The effective reciprocal of the effective resistance is equal to the sum of the reciprocal of the individual resistances, that is 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Formula is that one. Here all resistors are equal, so 1 by R plus 1 by R plus 1 by R plus 1 by R plus 1 by R. If there are 3 resistors, it is 3 by R. If there are 5 resistors, 5 by R. If there are n resistors, it is n by R. So 1 by Rp is equal to n by R. So Rp is equal to R by n. When n resistors with equal resistance are connected in series, this is the effective resistance. The same n resistors of equal resistance are connected in parallel, the effective resistance is R by n. The aim of the problem is ratio of their effective resistances Rs by Rp is equal to how much? Rs by Rp is equal to Nr divided by R by N. R cancel. If this N goes here, it's N power minus 1, though N. So this Rs by Rp is equal to N square. So answer is N square, or say N square is to 1. Yes, it is in the second option B. N square is to 1 is the answer for this problem. Pass on to the next, 25. Two conducting wires X and Y of same diameter but different materials are joined in series across a battery. If the number density of electrons in X is twice than in Y, then the ratio of drift velocity of electrons in these two wires is dash. Let me repeat. Two conducting wires X and Y of same diameter, same radius, same thickness, same cross-sectional area, but different materials are joined in series across a battery. If the number density of electrons, that is electron density, as a charge density, as a number of electrons per unit volume, if the number density of electrons in X is twice than in Y, then the ratio of drift velocity of electrons in these two wires is dash. Yes? Let X and Y, this is X and this is Y. The two are different materials. One is a copper, another one is aluminum. Different materials, but both wires are having same diameter, used to represent resistance. This is one wire and this is another wire. The diameter of the both wires same, so radius also same. So same diameter, these two wires are connected in series with a battery. Same diameter, that means radius, diameter is same, radius is same, so pi r square is same, that is area is same, cross-sectional area. Different materials in சொன்னாலே it is number of electrons per unit volume differs. அதை clear mention பண்றாங்க. If the number density of electrons in X is twice than in Y, number density or say electron density or say charge density or say number of electrons per unit volume in X is twice than in Y. So in X it is Nx, let be Nx is equal to 2n and Ny is equal to n. Am I right? Number density in X is twice. If the number density in Y is n, then in X, Y, the wire X it is 2n. That's mention பண்றாங்க. The number density of electrons in X is twice than that in Y. In Y if it is n, in X it is 2n. That is the meaning for the statement. The ratio of the drift velocity of the electrons. So Vdx wire is to Vdy. Drift velocity of the electron in the wire X is to drift velocity of the electron in the wire Y is a question mark. So drift velocity, number density or number of electrons per unit volume, area. For all these when battery is connected, the current I flows. So what is the relationship between the current and drift velocity? Already in one question during your discussion, previous discussion, we have crossed this one, NA VDE. Here the two wires X and Y, same diameter but different materials, whatever it may be. When two are connected in series, the current I is same in both wires. In series connection, the current is same, potential differs. In parallel connection, the potential is same, current differs. So the current is same in both first wire, I is equal to Nx, A is same diameter for both wires, so same cross-sectional area. And Vdx differs, the charge of the electron is always constant in any wire, any material. And this is for the first case. For wire Y, The current is same, II. It is Ny A into V dy into E. So since the current is same in both wires, we can equate the two equations. Nx into A into V dx into E is equal to Ny into A V dy into E. Instead of Nx, we can substitute 2n. Number density differ ஆகுது, அது ஒன்று தான் ப்ராப்ளமே இங்கே. ஸோ Nxக்கு பதிலாக 2n A V dx E. Number density in Y is n A V dy into E. So you can cancel n cancel A cancel E cancel. What is your aim? V dx by V dy. So V dx by V dy, meaning drift velocity of the electron in the conductor x by drift velocity of the electron in the wire y. It is equal to V dx by V dy. These two goes there, so the result becomes 1 by 2 or even say 1:2. So the answer must be 1:2 for this problem. It's also a simple one. Number density, you must know the meaning for that one. Number of electrons per unit volume. Different materials given, so different number density available. That's why different materials. Since n differs, they are called different materials. Next, 26. The sequence of color bands in two carbon resistors R1 or R2 are given. 1 brown, green, blue, and another one orange, black, green. Two carbon resistors are given. In one carbon resistor whose resistance is R1, the color bands are in the sequence brown, green, blue. In another one it is orange, black, green. The ratio of the resistances. For individual you have to calculate the resistance and then find the ratio. Repeat பண்றேன். The sequence of colored bands in two carbon resistors R1 and R2 are, first one brown, green, blue, and another one orange, black, green. The ratio of their resistance is dash. For this one we have to recall the color code in carbon resistors. The color code in carbon resistors, it is familiar for you. Yes, it is given as black, brown, red, orange, yellow, green, blue, violet, grey, white. In this sequence, the color code 0, 1, 2, 3, 4 till 9. If the color is blue, the number is 6. If the color is yellow, it is 4. From this color code only, if this color code is known and if the colors are in this sequence only and numbers also in the same sequence running number, then only it is possible to find the resistance of any resistor in the carbon resistors. Say in the first case, brown, first color band, second one is green, another one is blue. Here tolerance ring is not given. If it is not given, the tolerance value is plus or minus 20%. In both resistors it is plus or minus 20%. We need not bother about the tolerance ring. Any ratio கேக்குறாங்க cancel ஆயிட போகுது. Just value of resistance மட்டும் கொடுத்தா போதும். Say this first color represent first significant figure. What is the color? Brown. It is 1. And the second color is green. Second significant figure. Brown it is 1, number 1 is given. For green the number is 5 is given, it is 5. First significant figure, second significant figure, and blue, the third color represents number of zeros followed by these two numbers. Or in other words, number of zeros raised to the power of 10. Say for example blue is number 6. Nothing but 10 to the power 10 raised power, the number of blue is 6. So that 6 is there. This is a way to find the resistance using the color code in a carbon resistor of the three colors. First color represents first significant figure. Second color represents second significant figure. Third color represents number of zeros. 6 zeros போடணும் 15 பக்கத்தில், or say 10 raised power that number, that means number of zeros corresponding to that third color. So what is the resistance of the first color code resistance? R1 is equal to 15 10 power 6 ohm. The second case, same problem, orange, black, green. It is orange, black, green. For orange, the first significant figure, orange is 3, number 3. For black, the number is 0, second significant figure. Multiply by 10 raised power, the number of green, corresponding to green. Green is number 5. So, raised to the power 5. This is a way to find the resistance value. So, this R2. But the problem is the ratio of the two resistances R1 by R2 is equal to 15 into 10 to the power 6 by 30 into 10 to the power 5. Yes, if 10 power 5 goes to numerator, it is 10 power minus 5. 10 power minus 5, 10 power 6, it is 10 power 1. 10. 10 into 150, sorry, 15, 150 by 30. Cancel பண்ணால் this is 5. So answer for the problem is 15 by 3, 5. Yes, option C is correct. Instead of one problem, two problems combinedly given, that is two carbon resistors, and the ratio of the resistances to be calculated. In the circuit shown, R1 is 4 ohm, R2 is equal to R3, that is 15 ohm, R4 is 30 ohm, 30, and EMF of the battery E is 10 volt. The equivalent resistance of the circuit is dash. So a circuit is given. Yes, here is a circuit. In this circuit, R1 is 4 ohm, R1 is 4 ohm, R2 is equal to R3, R2 is equal to R3, which is 15 ohm, and R4 is 30 ohm. The EMF of the battery is 10 volt. What is the equivalent resistance of circuit? The circuit, the given circuit is little bit complicated. No, it is very simple circuit. Reason, in this circuit, this resistor is connected diagonally. The resistance is connected diagonally, that means instead of connecting the resistor in between these 2 points, yes, this end may be connected here also, that is equivalent to connecting here and equivalent to connecting here. The resistance R4, instead of connecting diagonally here, we can connect the same resistor in this way. This is the resistor R4, meaning the circuit is not changed, the values are not changed. Instead of connecting at this end, you can bring this end at this point, and you can bring this end at this point. So diagonal வரதுக்கு பதிலா straight lineலயும் வரலாம். Straight lineல வந்தா என்ன மீனிங்கோ அதே மீனிங் தான் diagonalல வந்தாலும். So I can redraw this diagram. Yes, this is a battery, and this is R1, and this is R2, and this is R4. See what I told? This is R3. This R4 diagonally decorating வேல கனெக்ட் பண்ணிருந்தாங்க, அதை நான் ஸ்ட்ரைட் லைன்ல மாத்திக்கிறது தான். ஸோ இங்கே இருந்தாலும் என்ன பொட்டென்ஷியலோ அதே தான் இங்கே இருந்தாலும், ஸோ இந்த வயர் இங்கே இருந்தாலும் என்ன பொட்டென்ஷியலோ அதே தான் இந்த இடத்துல இருந்தாலும். ஸோ ஈவன் இஃப் யூ disconnect this R4 and connect here, R4, this R4 is connected here, no change in potential difference. Same meaning here also occurs, meaning R2, R3, R4, all these three are in parallel combination. Why? The current delivered by this battery is I, as that current I flows here, passing through I1, passing through I2, passing I3. So I1, I2, I3, three different currents are divided agudhu. When current differs, then potential is same. That's why you say it is parallel combination. So R2, R3, R4 are parallel. R2, R3, R4 are in parallel combination. For parallel combination, the formula is 1 by Rp is equal to 1 by R2 plus 1 by R3 plus 1 by R4. That is 1 by Rp is equal to 1 by R2. R2 is given as 15 and R3 is given as 15. R4 is given as 30. So take LCM, that is 30. Here is 15, 2 times 2 plus 2 plus 1. It is 5 by 30 is 1 by Rp. So Rp is equal to 30 by 5. It is 6. So what is the combination of these three resistances? It is 6 ohm. Now this combination is in series with R1. Reason, the current flowing through this R1 is same as the current flowing through this Rp, all three combinedly. Therefore, R1 and Rp are in series combination. Therefore, the formula for series combination is R1 plus R2 plus R3 plus R4. So it is R1 plus Rp. So R is equal to effective resistance totally is R1. R1 is given in the problem 4 ohm. And Rp is 6 ohm, so the result is 10 ohm. Answer for the problem is 10 ohm. These three are in parallel and that parallel combination is connected in series with that one. So net resistance of circuit is 10 ohm. Answer for that problem is 10 ohm. And even in this same problem, additional one question கேட்டிருக்கலாம். What is the current supplied by the battery? What is the current supplied by the battery? Now use Ohm's law. V is equal to IR. I is equal to V by R. V is given 10 volt. Net resistance is 10 ohm. So 10 by 10 is 1 ampere. So even இதே problem one more question add பண்ணலாம் or new problem coin பண்ணலாம். What is the current supplied by the battery கேட்கலாம், or what is the current passing through the resistance R1 கேட்கலாம், or what is the current passing through R2, R2, R3, R4, any problem using Ohm's law. In this problem, in this circuit, the equivalent resistance of circuit is 10 ohm. Option A is correct. Next, the resistance of a wire of uniform diameter D and length L is R, capital letter R. The resistance of another wire of same material but diameter 2D and length 4L would be dash. Again, the problem is related with resistance, length, diameter. Diameter means radius. Radius means cross-sectional area. 28. The resistance of a wire of uniform diameter D, meaning radius is R, meaning R means pi R square, cross-sectional area is A, and length is L, the resistance is R. So the resistance of a uniform wire whose diameter is D, length is L, resistance is R. Diameter is D, meaning resistance is, radius is R. Radius R na diameter half. D by 2 is R. R vandana pi R square. Pi R square is nothing but area. So on the wire ku area indirect கொடுத்திருக்காங்க, length கொடுத்திருக்காங்க, resistance R னு கொடுத்திருக்காங்க. The resistance of another wire. The problem, the resistance of another wire of same material, that is important. Same material means specific resistance or say resistivity is constant. இது கான்ஸ்டன்ட் எஸ்டாப்ளிஷ் பண்ணுறதுக்காகவே ப்ரீவியஸாக ஒரு ப்ராப்ளம் நம்ம டிஸ்கஸ் பண்ணிடணும். ஒரே ஒரு ப்ராப்ளம் ரொம்ப டீட்டெயிலாக. The resistivity is constant, same material, thick wire, thin wire, short wire, long wire. For one material, for all four wires, rho is constant. Same material, but diameter is 2D. As diameter is 2D, radius is 2R. As radius is 2R, and the cross-sectional area is also changing, it instead of pi R square, it is pi into 2R the whole square. There it is, area is pi r square. And here diameter is 2r, so 4r square varum. And length 4L, length is not L, it is 4L. What is the resistance nu kekranga? So what is the relation to the resistance, length and area? It's a well known formula for you. The resistance of a wire at a given temperature depends on or directly proportional to length and inversely proportional to cross sectional area. At a given temperature, that is Ohm's law. At a given temperature, R is proportional to L and inversely proportional to area. So R is equal to rho into L by pi R square. Area badala. So this is for first wire whose length is L and radius is R by giving the diameter D. For the second wire whose resistance is R1, same material சொன்னாங்க, resistivity or specific resistance rho, same material, and now the length is 4L by pi into, instead of R it is 2R, so 2R the whole square. That is R1 is equal to rho into 4L by, it is 2 square is 4 and here it is pi R square. 4 cancel, so it is rho L by pi R square. Equation number 2. See the equation 1 and 2. Rho L by pi R square is R. Second to equation 2, rho L by pi R square தான் வந்திருக்குது. திரும்ப அதே ஃபார்முலா தான் வந்திருக்கு. So R and R1 both are equal, meaning the resistance for this and for the second wire also R. First wire length L, diameter D, resistance R. Second wire length 4L, diameter is 2D. Now what is the resistance கேட்டாங்க? For that wire also the resistance is R, as we have proved. So answer for this problem 28, it is C. Let us see the next. 29. The resistance of a conductor is 5 ohm at 50 degrees Celsius and 6 ohm at 100 degrees Celsius. Its resistance at 0 degrees Celsius is dash. Let me repeat the sum. The resistance of a conductor is 5 ohm at 50 degrees Celsius and 6 ohm at 100 degrees Celsius. What is the resistance at 0 degrees Celsius? Listen. Let the resistance be 5 ohm at 50 degrees Celsius, meaning R1 is 5 ohm at T1 of 50 degrees Celsius and 6 ohm at a temperature of 100 degrees Celsius, that is R2 when the temperature is T2. Then what is the resistance at 0 degrees Celsius? R at 0 degree is the question mark. See, the problem is about the relation between the resistance and temperature. There is temperature coefficient of resistance of the material. As for Ohm's law, at a given temperature, we can calculate the resistance. But when temperature varies, resistance also varies. That is, the problem is coming from the concept temperature coefficient of resistance, that is, particularly in metals, when temperature increases, resistance also increases. When temperature decreases, the resistance also decreases. Positive temperature coefficient of resistance, what we say alpha value. Whereas in the case of semiconductors and the insulators, when temperature increases, the resistance decreases. When temperature decreases, resistance increases. Negative temperature coefficient of resistance. That's why semiconductors are conducting electricity. As temperature increases, resistance decreases, conductance increases. So what is the relation between the temperature and the resistance? Listen, we know the basic concept. Let's recall the concept involved in this problem. Let R naught be the resistance at 0 degrees Celsius, and when temperature increases by T degrees Celsius, the resistance becomes RT. What is the increase in resistance? RT minus R naught. The change in resistance is directly proportional to resistance at 0 degrees Celsius and the rise in temperature or say increase in temperature. the basic fact. On what factors does the increase in resistance depend? One factor, resistance at 0 degree Celsius. Another factor, the increase in temperature, say rise in temperature. This RT minus R0 is equal to some constant, proportionality constant. Let that constant be alpha. This is directly proportional, where this one is alpha, a proportionality constant. What we named this one as? Yes, that's correct. Temperature coefficient of resistance. Temperature coefficient of resistance, R0 into T, or say RT is equal to, if you bring this minus R0 there, plus R0, alpha R0 T, or say RT is equal to R0 into 1 plus alpha T. So this is a linear equation. It is a basic equation what we have crossed in our textbook, the subject. Resistance at T degree Celsius is equal to resistance at 0 degree Celsius into 1 plus alpha T. Alpha is temperature coefficient of resistance. For one material it is a constant. So we can use this formula for this two set of data. Instead of RT, put R1. R1 is equal to R0 into 1 plus alpha T. R0 into 1 plus alpha T1. R1 is equal to this, that is R1 is equal to R0 into 1 plus alpha T1. R2 is equal to, let me write, R1 is equal to R0 into 1 plus alpha T1. And R2 is equal to R0 into 1 plus alpha T2. Divide the first by second. R1 by R2 is equal to R0 cancel, 1 plus alpha T1 by 1 plus alpha T2. Cross multiply, rearrange and simplify. செஞ்சுட்டு வரீங்களா? Yes, cross multiply பண்ணா R1 plus R1 alpha T2 is equal to R2 into R2 alpha T1. Bring the alpha terms to the left side. So alpha is equal to, it is R2 minus R1 by R1 T2 minus R2 T1. Doubt are that verify பண்ணி பார்த்துக்கலாம், derive பண்ணி பார்த்துக்கலாம். So it is R1 into R1 plus R1 alpha T2. It is equal to R2 alpha T1. R2 plus R2 alpha T1. Yes, here is R2. Bring this R1 to that side. So R1 alpha T2 retain here. Bring this alpha term here. Minus R2 alpha T1. It is equal to R2. This one comes there minus R1. So alpha taken as common. R1 T2 minus R2 T1. It is equal to R2 minus R1. So alpha is equal to, இது தான் நான் முதல்ல எழுதுனேன், R2 minus R1 by R1 T2 minus R2 T1. Let us substitute the value. To calculate R0, first we need alpha. For that purpose we are going to calculate this alpha value. R2 minus R1 is 6 minus 5 by R1 is 5 ohm. T2 is 100 degree Celsius. Minus R2 is 6. T1 is 50. So this alpha is equal to 1 by 500 minus 300. 6 into 50, 300. 500 minus 300, 200. 1 by 200 is the answer for this alpha value. Per degree Celsius is the unit of alpha. Per degree Celsius. Now come to this formula. They are asking R0. To calculate R0, we can use this formula as R0. R0 is equal to RT by 1 plus alpha T. R0 is equal to, we can take either this first set of value or even second set of value. இதையே வச்சு calculate பண்ணலாம் or இந்த set of data வச்சு calculate, எதை calculate பண்ணலாம் சொல்றேன். But you have to take R1 T1 எடுத்துக்கணும், இல்லைன்னா R2 T2 எடுத்துக்கணும். அதில் R1 இதில் T2 எடுத்துட்டா தப்பாக வரும். ஸோ இதில் calculate பண்ணாலும் ஒரே ரிசல்ட் தான் வரும், இதில் calculate பண்ணாலும் ஒரே ரிசல்ட் தான் வரும். நான் இதில் எடுத்து calculate பண்ணுறேன். RTக்கு பதிலாக it is 5 ohm by 1 plus alphaக்கு பதிலாக 200 into Tக்கு பதிலாக temperature is 50. So it is 50 by 200 is 4. So R0 is equal to 5 by 1 plus 1 by 4. R0 is equal to, it is 4, it is 4 plus 1, so it is 5 by 5 by 4, 4 goes to numerator, 5 cut ஆயிடுச்சு, so R0 is 4 ohm. So answer for the problem is 4 ohm. To calculate the resistance at 0 degree Celsius, the formula required is RT equal R0 into 1 plus alpha T. R0 equal RT by 1 plus alpha T. If alpha is known, then only it is possible to calculate R0. To calculate alpha, we are using this two set of data, that is alpha is equal R2 minus R1 by R1 T2 minus R2 T1. So it is a good problem. Alpha calculate pandrom, temperature coefficient of resistance, at the same time resistance at 0 degree Celsius calculate pandrom. Let us pass on to the next. 30. An electric bulb is rated 220 volt and 100 watt. An electric bulb is rated 220 volt and 100 watt. Power consumed by it when operated on 110 volt is dash. An electric bulb is rated marked by 220 volt and 100 watt. 100 watt means power. The power consumed by it when operated on 110 volt, meaning 220 volt potential drop ஆகுது, 110 volt ஆகுதுன்னா what is the power? 220 volt potential இருந்தால் power is 100 watt. 110 volt potential drop ஆயிடுச்சுன்னா what will be the power னு கேட்குறாங்க. So list out the data. The potential is 220 volt, power is 100 watt. What will be the power? ரெண்டாவது பவர் அப்போ 1 இது 2. When the potential is dropped to 110 volt, அப்போ இது 1 இது 2. So what is the relationship between the potential and power? What is power? Product of voltage and current. The product of potential difference and current is called power. P is equal to V into I. As per Ohm's law, V is equal to IR. I is equal to V by R. I is equal to V by R. So it is V into V, V square by R. நீங்கள் கேட்கலாம், ஏன் சார் விக்கு பதிலாக ஐஆர் போட்டு ஐ ஸ்கொயர் ஆர் போடலாமே? ஐ ஸ்கொயர் ஆர் போடலாம், ஆனால் ஐ எனக்கு இங்கே கொடுக்கவே இல்லை, இன்வால்வ் ஆகலை. தட்ஸ் ஐ ஓம்ஸில் வி ஈக்குவல் டு ஐஆர் ஓம்ஸில் ஆகலை. வி ஈக்குவல் டு ஐஆர் போட்டு ஐ இன்வால்வ் பண்ணுறதுக்கு பதிலாக ஐ இஸ் ஈக்குவல் டு வி பை ஆர் போட்டு ஐயை நான் வி பை ஆராக மாற்றிட்டேன். சின்ஸ் ஐ இஸ் நாட் இன்வால்வ் in the problem, not given. So the problem is P is equal to V square by R. So write it. P1 is equal to V1 square by R and P2 is equal to V2 square by R. Why I am writing RR? For one bulb, for one filament, tungsten filament, one resistance. ஒரு வயருக்கு ஒரு ரெசிஸ்டன்ஸ் தான் இருக்க முடியும். So the resistance is same. அதே பல்பு, அதே ரெசிஸ்டன்ஸ். That's why RR யூஸ் பண்ணுறேன். So P2 by P1 divide பண்ணுறேன். P2 by P1 is equal to V2 square by R by V1 square by R ன்னு தலைகீழாக போட்டு பெருக்கணும். That is R by V1 square. R cancel. So what is P2 by P1? It is equal to V2 square. V2 is 110. 110 into 110 by V1 square is 220 into 220. 0 0 cut, 0 0 cut, 1 11s, 2 11s, 1 11, 2 11s, 2 2s are 4. So the result is P2 is equal to 1 by 4 into P1. What is P1? It is already given 100 watt. 100 by 4, 100 by 4 is 25 watt. So 25 watt is the answer for this problem. Actually the bulb is marked by, rated by 220 volt and 100 watt. 220 volt potential இருந்தால் EMF இருந்தால் 100 watt பவர் வரும். 220 voltங்கிறது 110 volட்டாக டவுன் ஆச்சுன்னா பொட்டென்ஷியல் ட்ராப் ஆனால் the power comes to 25 watt. That is a proof. Let us see the next one. 31. In the given network, a circuit is given. The effective resistance between the points A and B is, see the circuit. in the given network, the effective resistance between the points A and B is dash. Effective resistance kekranga. So here also the problem is about number of resistors in series and number of resistors in parallel. How is it possible? See the circuit. This Wheatstone's bridge. Circuit பார்த்தா Wheatstone's bridge தான் வருது. இது Wheatstone's bridge actually. 4 resistors connect to the 4 arms of the electrical bridge P, Q, R, S. 4 resistances connected on the 4 arms of the electrical bridge, what we call Wheatstone's bridge. And this is a galvanometer whose resistance is 10 ohm. Galvanometer connect பண்ணுறது பதிலா galvanometer resistance connect பண்ணிருக்கேன். Everything is same in physics. Let this point be C, let this point be D. See, listen carefully. In this Wheatstone's bridge, P, Q, R, S, the bridge is balanced. Do you agree? Yes. The bridge is balanced. Why? P by Q is equal to R by S. 10 by 10 is equal to 10 by 10. So the bridge is balanced. The bridge is balanced means there will be no current through the galvanometer. That is the concept we have studied. We are familiar. In Wheatstone's bridge, when the galvanometer shows zero deflection, meaning when no current passes through this galvanometer, when the potential difference between C and D is 0, or say potential at C is equal to potential at D, then no current flows through this galvanometer through this path, then the bridge is said to be balanced, that is P by Q is equal to R by S. Since the bridge is balanced, P by Q equal R by S, 10 by 10 equal 10 by 10, that is 1 is equal to 1, no current passing through the galvanometer. In the point da venum. This valiya current pogala. That means, inga vara current I, it is passing as I1 through this resistor. The same I1 passing through this resistor also. Why? No current is passing through this resistor. That is concept. As the bridge is balanced, here no current is flowing. So, this current, all current is as the two currents are same, these two are in series connection. Similarly, the current is passing through this I2. I2 is flowing as I2 through this resistor. Here, no part of the current is passing. Reason, no current passing through this path since the bridge is balanced. So, this current current. So, once again, these two resistors are in series combination. So, I can redraw this circuit as, listen, this is one 10 ohm, this is another 10 ohm, this is one 10 ohm, this is another 10 ohm. That's all. So, no meaning for this resistor. Reason, no current passing through this galvanometer. That is called Wheatstone's bridge. But this is 10 ohm, this is 10 ohm, this is 10 ohm, this is 10 ohm. Reason, the current passing through this resistor also passing through the resistor. Since the current is same in these two resistors, these two are in series. Same way, these two are in series. In the case of series connection, you know the formula, RS1 or RS is equal to, RS1 is equal to R1 plus R2 plus R3. Yes, come on, 10 plus 10. R1 plus R2, that is 10 plus 10, it is equal to 20. Similarly, RS2, these two are in series. So, what is effective resistance in this combination? It is 10 plus 10, so it is 20. Now, these two combinations are in parallel to each other. Am I right? Either combine money 10 to 20 ohm, either combine money 20 ohm. So, draw the equivalent circuit. Yes. Simplify பண்ணிட்டோம். So, இந்த நெட்வொர்க்கை எப்படி simplify பண்ணணும், அதே நெட்வொர்க்கை எப்படி simplify, this is 20 ohm, this is 20 ohm, between A and B, what is effective resistance கேட்டிருக்காங்க. Now, these two are parallel combination. So, 1 by Rp is equal to 1 by R1 plus 1 by R2, 1 by 20 plus 1 by 20, 2 by 20, 1 by 10. So, 1 by Rp is 1 by 10, Rp is equal to 10. So, what is the effective resistance in the circuit or network? The result is 10 ohm. So, avangale already 5 resistance 10, 10, 10, 10 கொடுத்தாங்க. Total resistance எவ்வளோனா அதுவும் 10 தான் வருது. In the given network, the effective resistance between the points A and B is 10 ohm. That is the correct answer. Let us pass on to the next. 32. The resistance of 20 centimeter long wire is 5 ohm. The wire is stretched to a uniform wire of 40 centimeter length. The resistance now will be dash. Let me repeat the sum. The resistance of 20 centimeter long wire is 5 ohm. The wire is stretched to a uniform wire of 40 centimeter length. The resistance now will be. Say in this problem, let L1 be the initial resistance. This is a wire whose length is L1, that is L, initial length, whose resistance is, whose thickness is, or say cross sectional area is A or say A1. A1 is pi R1 square. Let A1 be the thickness or cross sectional area of this wire, whose resistance is R1. That R1 is R is equal to 5 ohm. And L also given as 20 centimeter. Repeat பண்றேன். The resistance of 20 centimeter long wire is 5 ohm. Let L1 be the initial length, which is equal to L, 20 centimeter. At the time the cross sectional area is A1, whose resistance is R1, nothing but R, let it be 5. கொடுத்துருக்காங்க. The wire is stretched to uniform wire of 40 centimeter length. And the wire is stretched பண்றாங்க. When the wire is stretched uniformly to 40 centimeter length, L2 is equal to 40 centimeter. So 20 centimeter 42 times stretch பண்ணியிருக்கிறாங்க. So wire stretch பண்ண இழுத்தோன்னு elongate பண்ணிட்டே போகணும். எக்ஸ்டென்ஷன் வந்துக்கிட்டே இருந்தால் திக்னஸ் குறைஞ்சிக்கிட்டே இருக்கும். ஸோ திக்னஸ் குறைஞ்சிக்கிட்டே இருக்கும். அப்போ கிராஸ் செக்ஷனல் ஏரியா சேஞ்ச் ஆகும் A2. அண்ட் வாட் இஸ் த நியூ ரெசிஸ்டன்ஸ்? இதுதான் கொஸ்டின் மார்க். If L1 is the initial length, whose resistance is R1, if that wire is stretched to 40 centimeter, that is L2 is given, what will be the new resistance? Initially, before stretching, A1 be the area of cross section. After stretching, the cross section area is A2. கண்டிப்பா area of cross section change ஆயிருக்கும், thickness change ஆயிருக்கும், thickness குறைஞ்சிருக்கும், thin ஆயிருக்கும் கம்பி. ரீசன் அந்த கம்பியை தான் நம்ம நீட்டிக்கிட்டே போகிறோம். 20 centimeter length 40 centimeter மாற்றணும். அப்போ how many times the wire has been stretched? How many times the wire has been stretched? Yes, it is correct. L2 by L1. L2 by L1 is equal to 40 by 20 centimeter. It is 2. You are stretching the wire by 2 times. Once again, here also the problem is related to resistance, length and cross-sectional area. The resistance of wire is directly proportional to length and inversely proportional to cross-sectional area. R is equal to the proportionally constant specific resistance or resistivity, L by A. Write the equation for first one. R1 is equal to rho into L1 by A1. R2 is equal to rho into L2 by A2. Why it is same rho? Adhe wire, same material. For one material, one rho is there. Specific resistance always constant. In number of problems, we have mentioned that one. Divide the second by first. R2 by R1, it is equal to rho cancel ஆயிடுமா? So L2 by A2 divided by L1 by A1. L2 by A2 divided by L1 by A1. Divided by L1 by A1 means multiply inverse and multiply. That means L1 by A1 பதிலா A1 by L1. Here L2 is known, L1 is known, L2 by L1 எனக்கு தெரியும், 2 போடலாம். But A1 by A2 தெரியாது. A1 by A2 எனக்கு தெரியாது, but it is indirectly known. A wire or any wire is a cylinder. Do you agree? Wire is a cylinder. Cross section area is A, length is L, nothing but pi r square L, pi r square H. So if the wire is stretched, cylinder is stretched, length increase ஆகுது, thickness decrease ஆகுது, but volume remains same. That is the important concept drawn from mathematics. If a cylinder is stretched uniformly, its length is increased, whereas thickness, volume decrease, area, cross-sectional area decrease ஆகுது. So, length increase ஆகுது, cross-sectional area decrease ஆகுது, but volume of the cylinder remains same. எங்கேயும் போகல, அது உள்ளதா இருக்குது மெட்டீரியல். Thin wire, thick wire, thin wire ஆயிருக்கு, that's all. Therefore, pi r square h is constant, that is volume is constant. Length change ஆகுது, cross sectional area change ஆகுது சிலிண்டருக்கு, ஆனால் வால்யூம் சேஞ்ச் ஆகாது. அந்த வயர் கட் ஆனால் தான் சேஞ்ச் ஆகும், அந்த வயர் அப்படியே தான் இருக்குது, அந்த வயருக்குள்ளே இருந்த மேட்டர் அப்படியே தான் இருக்குது, ஸ்ட்ரெச் பண்ணியிருக்கோம் அவ்வளோதான். ஸோ லென்த் இன்க்ரீஸ் ஆச்சு, கிராஸ் செக்ஷன் ஏரியா டிக்ரீஸ் ஆச்சு, பட் வால்யூம் ரிமைன்ஸ் கான்ஸ்டன்ட். வால்யூம் ஆஃப் சிலிண்டர் ஃபார்முலா இஸ் பை ஆர் ஸ்கொயர் ஹெச். பை ஆர் ஸ்கொயருக்கு பதிலாக ஏ போடலாம். ஹெச்னா ஹைட் ஆஃப் த சிலிண்டர், நம்மக்கிட்ட வயர், வயரோட ஹைட்னா வயரோட லென்த்து எல். ஏ இன்ட்டு எல் இஸ் ஈக்குவல் டு கான்ஸ்டன்ட். வாட் டஸ் இட் மீன்? A1 L1 is equal to A2 L2, it is equal to A3 L3 equal to A4 L4 equal to A5 L5. So A1 by A2 it is equal to A1 by A2, it is equal to L2 by L1. So A1 by A2 calculate பண்ணிட்டோம். Therefore, what is R2 by R1? Once again come to the original formula. R2 by R1 is equal to, already it is L2 by L1. Now A1 by A2 பதிலாக it is L2 by L1. So R2 by R1 is equal to L2 by L1 க்கு பதிலாக I have calculated L2 by L1 is 40 by 20. In our problem, 20 centimeter wire is stretched into 40 centimeters. So how many times it has been stretched up? 40 by 20, 2 times. So L2 by L1 is 2 into 2, 2 square. Number மாற்றி கேட்டாங்கன்னா you can simply give n square. n square, n times stretch பண்ணாங்க அப்போ n square. இப்போ இதே 80 சென்ட் 20 சென்டிமீட்டர் வயர் 80 சென்டிமீட்டர் ஆகிட்டு இருந்தால் 80 by 20 4 times. அப்போ 4 square, n is 4. ப்ராப்ளம் மாற்றலாம், நம்பர் மாற்றலாம். ஜெனரல் ஃபார்முலா இஸ் n square. நான் இங்கே 2 square. It is equal to 4. R2 is equal to 4 into R1, nothing but 4 into R. 4 into initial resistance is given the problem 5. So 20 ohm is the answer for the problem. If a wire of 20 centimeter length having the resistance 5 ohm is stretched uniformly to 40 centimeter, now the resistance becomes 20 ohm. We cannot exactly predict the proportionality. Yes, option is there. C is correct. Third option. See the next one. A 3 equal resistors, each of resistance R. 3 equal resistors, each of resistance R, connected so as to form a triangle. 3 resistors connected at the 3 sides of the triangle. Yes, for triangle 3 sides are there. The equivalent resistance across any 2 corners. Any 2 corners. Let me draw the diagram. This is one resistor. This is another resistor. And this is another resistor. Let it be A, B, C. 3 equal resistors. Let it be R. சொல்லிட்டாங்களே ஈக்குவல்னு. 3 equal resistors, each of resistance R, connected so as to form a triangle. The equivalent resistance across any 2 corners, B and C, across B and C எடுக்கலாம், R across A and B எடுக்கலாம், R across A and C எடுக்கலாம், நான் across B and C எடுக்கிறேன். Between B and C, what is the equivalent resistance or effective resistance? Yes, it is possible to redraw the circuit. Bங்கிற பாயிண்ட்டையும் Cங்கிற பாயிண்ட்டையும் அப்படியே ரிட்டைன் பண்ணுறேன். Between B and C there is resistance R. About this point, now these 2 resistors are in series combination. You agree? Yes. Reason, இது வழியாக என்ன கரண்ட் போகுது அதே கரண்ட் தான் இது வழியாக வரும். ரீசன், இங்கே வேறு அந்த கரண்ட்டு பிரான்ச் ஆகி டிவைட் ஆகி வேறு பக்கம் போகிறது சான்ஸ் இல்லை. இதில் என்ட்ரு ஆகிற கரண்ட் அவ்வளவு கரண்ட்டு இதில் வரணும். when current is same, we say the 2 are in series connection. So across B and C, these 2 are in series connection. This is one resistor and this is another resistor. Let this point be B. அப்போ இந்த பாயிண்ட் சொல்ல A, C உள்ளதா இருக்குது. Therefore, this is R, this is R. About these points B and C, across B and C, the two are in series combination. When two resistors are in series combination, what is effective resistance? Effective resistance is sum of the individual. When two or more resistors connected in series, the effective resistance is equal to sum of the individual resistances. That is R1 plus R2. R1 plus R2 balenge R. That is Rs is equal to 2R. We can reduce this diagram like this. This is one resistor, how much? 2R. And this is one resistor, how much? It is R. Now these two are in parallel combination. About this resistor, these two are in series. You have calculated the net. Now the two are in parallel combination. For parallel combination, the formula is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. When two or more resistors are connected in parallel, the reciprocal of the effective resistance is equal to sum of the reciprocal of the individual resistances. That is 1 by R1 plus 1 by R2. 1 by R1 it is 1 by 2R plus 1 by R. We take this mathematical principle, simplify this one. 2R, in 2R is cancelled, its result is 1. Here R is cancelled 2, so it is 3 by 2R. So 1 by Rp is equal to 3 by 2R. Come on, Rp is equal to, that is R is equal to 2R by 3. So what is the answer for this problem now? It is 2R by 3. 2 by 3 into R. 2 by 3 is 0.66. 0.66 into R. Yes, it is absolutely correct. How is it possible? When two or more resistors connected in parallel, the effective resistance is always lesser than the least value. Here all are equal, R. Since in parallel combination, the effective resistance is lesser than the least. அப்போ ஆறுங்கிற வேல்யூ விட லெஸ்ஸர் வேல்யூ வரணும். எனக்கு ஆறுங்கிற வேல்யூ விட லெஸ்ஸர் வேல்யூ தான் வந்துடுது. 0.66 R வருது. 0.66 Rங்கிறது 1 R விட 0.66 Rங்கிறது லெஸ்ஸர் தான். So this answer is 100% correct. We can ensure, we can establish the answer. So the option A is correct, 2R by 3. Let's pass on to the next. A wire of length 1 meter is made into a circular loop and it carries a current of 3.14 ampere. The magnetic dipole moment of the current loop is, in the unit ampere meter square, is dash. Let me repeat. A wire of length 1 meter is made into a circular loop and it carries a current of 3.14 ampere. The magnetic dipole moment of the current loop is how much? Magnetic dipole moment, magnetic moment. Yes, the magnetic moment is nothing but dipole is the product of the current in the loop and area of the current loop. You know the concept? Magnetic dipole moment is, and magnetism is originating only from the current. When the current flows in circular path, magnetic field arises. So the current loop is behaving like the magnetic dipole whose value is I into A, current into area. Let us calculate. A wire of length 1 meter is made into a circular loop. This wire is made into a circular loop. That wire is made into a circular loop. So whose radius, whose circumference is equal to 1 meter. Am I right? That wire is made into a circular loop. That wire length of that wire is 1 meter. So the circumference of the wire must be 1 meter. So 2 pi R is equal to 1 meter. So R is equal to 1 by 2 pi. What is the radius of the circular loop? It is 1 by 2 pi. Mathematics. What is the magnetic? The current in the loop is, as it is given, the current I is 3.14 ampere. What is the magnetic dipole moment? Is the magnetic dipole moment, just now I mentioned, product of the current in the loop and the area of the current loop. That's why the unit is ampere meter square. Area meter square, current ampere meter square. அவங்களே கொடுத்துருக்காங்க யூனிட்டு. அந்த யூனிட் வச்சு கூட ஃபார்முலா எடுத்துகிட்டு வரலாம். This I into A, What is I? How much is I? 3.14. A means pi r square. So it is 3.14 into pi is again 3.14, or let it be pi. R square. R is 1 by 2 pi. R square is 1 by 4 pi square. R is 1 by 2 pi. R square is 1 by 4 pi square. 1 pi cancel. Pi means 3.4. 3.14, 3.14 cancel. So what is the rest? 1 by 4. So m is equal 1 by 4. 1 by 4 is nothing but 0.25. So 0.25 ampere meter square must be the answer for this sum. Yes, it is the option C. 0.25 ampere meter square. Yes, let us pass on to the next. 35. When a number of turns in a galvanometer is doubled, the current sensitivity, what will happen to the current sensitivity? When a number of turns in a galvanometer is doubled, the current sensitivity, say, galvanometer means moving coil galvanometer. In the moving coil galvanometer, there is a coil through which the current flows. The current carrying coil is placed in the magnetic field, uniform magnetic field. Hence, a torque is acting and making the coil to rotate. This is called deflecting torque. NIBA. Deflecting torque. The phosphor bronze wire provides a restoring torque C theta. This is a theory involved in the moving coil galvanometer. When these two are equal, the deflected coil is in equilibrium position, thereby you can note the deflection theta, thereby the current can be measured using this theory. Here this deflection produced by current theta by I. This theta by this I is nothing but NBA by C. What we call this one as current sensitivity. Deflection produced per unit current is defined as current sensitivity. Deflection produced per unit current. That current sensitivity is directly proportional number of turns, numerator, directly proportional to the magnetic field, directly proportional to the area of the coil, inversely proportional to the couple per unit twist, or say restoring constant, or say torque constant. So current sensitivity increase, number of turns is decreased. When number of turns in the galvanometer is double, when this one is doubled, current sensitivity also doubled. Reason the two are directly proportional. To increase the current sensitivity, number of turns should be increased, that is double. Current sensitivity also doubled. Bit B is increased and A is increased, C is decreased. Here we have to note a point. When number of turns in a galvanometer is increased, the current sensitivity is increased, but what about voltage sensitivity? See, in this equation, theta by I, it is equal to NBA by C. If you divide on both sides by the resistance of the galvanometer, that is resistance of the copper coil in the galvanometer resistance. ரெண்டு பக்கம் GL divide பண்ணுங்க, result is not affected. So current into resistance is nothing but voltage, V equal IR, Ohm's law. So theta by V is equal to NBA by C into G. Deflection produced per unit volt. Yes, this is voltage sensitivity. Not related to this question. This is voltage sensitivity. Deflection produced per unit volt. This deflection, that is this voltage sensitivity, directly proportional number of turns, directly proportional to magnetic field, directly proportional to area of the coil, inversely proportional to couple per unit twist, inversely proportional to G. சொல்லலாமான்னா இதை சொல்லலாம், இதை சொல்லலாம், இதை சொல்லலாம், இதை சொல்லக்கூடாது. Reason. In the galvanometer coil, rectangular copper coil, when number of turns is doubled, length is doubled, length is doubled, resistance also doubled. Why? Yes, the resistance is directly proportional to length of the wire. When number of turns is doubled, The length of that wire is doubled. So resistance also doubled. So resistance double அப்படின்னு சொன்னேன். Here is G is available. அப்போ double cancel ஆகிடும். Number of turns double ஆனால் resistance double ஆகும். அப்போ 2/2 cancel. 4 times ஆனால் 4/4 cancel. So increase in number of turns can increase the current sensitivity but cannot increase the voltage sensitivity. Reason, as the number of turns is doubled, since in denominator galvanometer resistance is available, that is the reason. In the denominator galvanometer resistance is available, as the number of turns is doubled, length is doubled, resistance also doubled, reason resistance directly proportional length of the wire. So double 2 cancel, so result maintain constant. So increase in number of turns increases the current sensitivity but not voltage sensitivity. So for this question the answer is increases twice. And number of turns increase ஆச்சு double ஆச்சு, current sensitivity double ஆகுது. That is option C is correct. Let us see the next one. A proton and an alpha particle are projected with the same velocity, normal to uniform normal perpendicular, normal to uniform magnetic field. The ratio of magnetic Lorentz force experienced by the proton and alpha particle is dash. Let me repeat. A proton and alpha particle are projected with the same velocity, normal to the uniform magnetic field. We know when charged particles are made to move perpendicular to the uniform magnetic field, they move in circular path. Motion of the charged particle in the uniform magnetic field, the concept, motion of the charged particle in the uniform magnetic field, when a charged particle moves perpendicular right angles to the uniform magnetic field, it describes circular path. Why? Centripetal force provided by Lorentz force, magnetic Lorentz force. The ratio of the magnetic Lorentz force experienced by the two. அதான் கேட்குறாங்க. Question number 36. Proton. Proton is 1h1. What is the charge of proton? 1e. 1e. 1e 1.6 10 power minus 19 coulomb. Alpha particle. What is symbol for alpha? 2he4. Now the alpha is nothing but helium nucleus. Alpha particle is nothing but helium nucleus, 2 protons, 4 minus 2, 2 neutrons. Alpha particle is nothing but helium nucleus. Alpha particle is made by 2 protons and 2 neutrons. One proton 1e, 2 protons 2e. So இதுவும் positive charge, இதுவும் positive charge. Charge value எவ்வளோனா 1e, இதுக்கு 2e. என்ன சொல்கிறாங்க? Move with same velocity for both. Both particles are moving with same velocity. Normal to the uniform magnetic field. Magnetic field is also same. One magnetic field. Perpendicular magnetic field, both of them are moving with the same velocity. What is the ratio of the magnetic Lorentz force? The magnetic Lorentz force given by, is another formula? Q into V vector cross B vector. Or say B Q V sin theta. When the particles are moving perpendicular to the magnetic field, as this theta is 90, then the force acting is also maximum, that is F is equal to BQV. Sin 90 is 1. Maximum force, maximum Lorentz force, that's why the particle moves in circular path. நம்ம இங்கே சர்க்குலர் பாத்துக்கு போக விடவே இல்லை ப்ராப்ளத்தில், அதுக்குள்ளே கட் பண்ணுறாங்க. வாட் இஸ் த ரேஷியோ ஆஃப் த ஃபோர்ஸஸ்ன்னு கேட்குறாங்க. அது போதும். ஸோ எஃப் ஆல்ஃபா ஃபர்ஸ்ட் ப்ரோட்டானுக்கு த ஃபோர்ஸ் ஆக்டிங் அண்ட் லொரென்ஸ் ஃபோர்ஸ் ஆக்டிங் அண்ட் த ப்ரோட்டான் இஸ் பி இன்ட்டு கியூக்கு பதிலாக 1e. வெலாசிட்டி இஸ் சேம் ஃபார் போத். ஆல்ஃபா பார்ட்டிகளுக்கு எஃப் ஆல்ஃபா இட் இஸ் பி, கியூக்கு பதிலாக now it is 2e v. So what is the ratio? The ratio of magnetic Lorentz force experienced by the proton and alpha particle. இதுக்கு ratio கேட்குறாங்க. Fp by F alpha is equal to, divide பண்ண BB cancel, VV cancel, EE cancel, 1/2, 1:2, that is the answer. That must be the answer. Yes, B is correct, option B. Pass on to the next. In Joule's calorimeter experiment, when a current of 1 ampere is passed through a coil for a known interval of time t, the temperature of water increases from 30 degrees Celsius to 33 degrees Celsius. When a current of 2 ampere is passed through the same coil, meaning same resistance, placed in the same quantity of water means the thermal capacity, the heat capacity, water equivalent constant W. And for the same time, the temperature of water increases from 30 degrees Celsius to dash. It's a good problem. In Joule's calorimeter experiment, let me repeat, in Joule's calorimeter experiment, when a current of 1 ampere is passed through a coil for a known time interval t, the temperature of water increases from 30 degrees Celsius to 33 degrees Celsius. When a current of 2 ampere is passed through the same coil, placed the same quantity of water for the same time, the temperature of water increases from 30 degrees Celsius to dash. Yes, listen. In a Joule's calorimeter experiment, when a current of 1 ampere, I is 1 ampere, pass through a coil for a known time, t is known time, the temperature of water increases from, that means theta 2 minus theta 1 is equal to 33 degrees Celsius minus 30 degrees Celsius. That is the first case. When a current of 2 ampere is passed, again, when a current of 2 ampere, is I1 vehicle, is I2 vehicle. To the same coil means resistance is same. Resistance is same. Same quantity of water, W is same, thermal capacity or say heat capacity or say water equivalent. And for the same time, the temperature of water increases from theta 2 minus theta 1. The second case is how much? This is from 2 from 30 degrees Celsius 2 தான் கேட்குறாங்க, meaning final தான் கேட்குறாங்க. At the end let us substitute the value. theta 2 minus theta 1 theta 1 நமக்கு from கொடுத்துட்டாங்க, 2 theta 2 கேட்குறாங்க. So how to approach the problem? As per Joule's calorimeter experiment, the heat produced as per Joule's law, come on, I square RT. The same amount of heat produced in Joule's calorimeter apparatus, when current flows through the coil dipped immersed in water, the heat is produced. How to measure that heat? Yes, you are correct. Theta 2 minus theta 1. This is called thermal capacity, the heat capacity. So the two H's are equal, two heats are equal. This is Joule's law and this is the heat calculated as per Joule's calorimeter experiment. So the two are equal. So W into theta 2 minus theta 1, it is equal to I square RT. Let us write this equation for first data. W into theta 2 minus theta 1 in the first case, sorry, second case, yes, second case, it is equal to I2 square RT. R and T are same. And write the same second set of data for the same equation, come on, this is the equation using the second set of data. Now let us write the equation using the first set of data. Theta 2 minus theta 1 in the first case, it is equal to I1 square RT. Divide this equation by this equation. Divide this one by this one. W cancel. RT cancel. What is the rest? Theta 2 minus theta 1 in the second case by theta 2 minus theta 1 in the first case, it is equal to I1 square by I2 square by I1 square. What is I2? 2 ampere. What is I1? 1 ampere. So 2 square 4 by 1, it is 4 by 1 is 4. So theta 2 minus theta 1 in the second case is equal to 4 into theta 2 minus theta 1 in the first case. So 4 into theta, first case theta 1 from 30 33 final is 33, initial is 30. So 3 degrees Celsius difference, 3 fours are 12 degrees Celsius. Theta 2 minus theta 1 in the second case is equal to 12 degrees Celsius. So what is theta 2? Yes, minus theta 1 plus theta 1 ஆச்சு plus 12. So theta 1 கொடுத்துருக்காங்களா அவங்க problem முடிகிற இடத்துல the temperature of water increases from 30 degrees Celsius to dash. அப்போ இது 30 degree Celsius plus 12 degree Celsius, it is equal to 42 degree Celsius. So really good problem. Relating the two equations, that is actual Joule's law and the way the formula required to calculate the heat evolved in Joule's calorimeter apparatus. 38. Consider a circular coil of radius 10 centimeter in an air medium. If 5 ampere current passes through it, what would be the magnetic induction at its center? Consider a circular coil. Say this is a circular coil of radius. So let it be A or even R. You can use any symbol. A is equal to 10 centimeter. Meter convert பண்ணனும் 10 to the power minus 2 meter. 5 ampere current passes through it. I is equal to 5 ampere current. What would be the magnetic induction at the center? That is B is the question mark. Circular coil சொல்லிருக்காங்க, number of turns involved. Let us check the problem again. Consider a circular coil of radius 10 cm in an air medium. Mu naught தான் வரும், mu r வராது. Air mu r is 1. Relative permeability. If 5 ampere current passes through it, what would be the magnetic induction at its center? So number of turns coil ப்ராப்ளத்தில் கொடுக்கல, so take it as 1. So what is the magnetic induction at the center of the circular coil? Even you are using this expression, your tangent galvanometer. Along the axis of the circular coil, along the axis of the circular coil at a distance x, yes, the magnetic field is mu naught Ni a square by 2 into a square plus x square the whole power 3 by 2. அதுவே at distance x க்கு பதிலா at this center னு கேட்டா அப்ப x is 0. x is 0 போட்டு simplify பண்ணா the equation becomes mu naught Ni by 2a. Yes, this is a magnetic induction or magnetic field produced at the center of the circular coil carrying current. Solve it. Mu naught 4 pi 10 power minus 7. In a number of turns not given, so take it as 1. Into I is 5 by 2 into A is 10 centimeter, 10 into 10 power minus 2. Yes, 1, 2, 2 2s for 4. 10 into 10 power minus 2. So here 2 into 5, 10. In the 10, in the 2 into 5, or a 10 cancel. Up in the 10 power minus 2, male 10 power plus 2. 10 power plus 2, 10 power minus 7. Minus 7, 10 power plus 2. A power m and a power n, a power m plus n. Up minus 7 plus 2, minus 5. So pi into 10 to the power minus 5, or 3.14 into 10 power minus 5. Tesla is the unit of magnetic induction or magnetic field, or even you can say it is Weber per meter square. Say which where is answer? Yes, the first option. It is the first option. Pi is pi into 10 power minus 5 Tesla. Let's pass on to the next. 39. Two circular coils have number of turns in the ratio 1:2 and radii in the ratio 2:1. If the same current flows through them, the magnetic fields at their centers will be in the ratio. The ratio of the two magnetic fields at the center of the two circular coils. That is the aim of the problem. Two circular coils have number of turns the ratio 1:2 and the radii in the ratio 2:1. Yes, this problem is also similar to the previous problem but slight modification. Listen. Two circular coils This is one circular coil and this is another circular coil. Having turns ratio N1 is to N2 is given 1 is to 2. Radii ratio A1 is a radius, A2 is a radius, so A1 is to A2, or even you can put R1 is to R2, 2 is to 1. The same current flows through the two circular coils II. So I1 is equal to I2 is equal to I. Then the magnetic fields in the ratio, that is the ratio of the two magnetic fields, B1 is to B2. Is the previous problem you have mentioned is the current flows through the circular coil. At the center, the magnetic field produced is given by the formula mu naught Ni by 2A. Just the 38 sum. So now they are asking the ratio. So it is for first one mu naught N1 I by 2A1. N1 A1. I is same. It is east. B2. B2 is mu naught N2 I by 2A2. So mu naught cancel, I cancel, 2 cancel. So it is N1 by A1 is equal to N2 by A2. Yes, what is the ratio of N1 by N2? It is equal to A1 by A2. Bring this A1 here, bring the N2 here. So what is N1 by N2? It is 1 by 2. What is A1 by A2? It is 2 by 1. So how to find the ratio? It is half, it is 2. So multiply by 2 in the numerator, 2 by 2 cancel, it is 1. 1 is to 4. That must be the answer for the problem. So the ratio is 1 is to 4. Yes, it is the option D. Fourth option. Pass on to the next step. In a tangent galvanometer, for a constant current, the deflection is 30 degree. In a tangent galvanometer, for a tangent galvanometer is a circular coil. Where is circular coil, copper coil is available. For a constant current, the deflection is 30 degree. You know that galvanometer works with the tangent law. Tangent law is the principle of tangent galvanometer. So the work the deflection is 30 degree occurs. That means, what is tangent law? The magnetic needle is suspended at a point where two uniform crossed magnetic fields act right angles to each other. It will be deflected along the direction of the resultant of two magnetic field. When two uniform magnetic fields act right angles to each other, the magnetic needle suspended at the center is deflected or comes to rest in the direction of the resultant of two magnetic fields. This is tangent law. So as per the statement, in the tangent galvanometer for a constant current I, the deflection is 30 degree. Let this one be the magnetic field BH, the natural Earth's magnetic field, horizontal component of Earth's magnetic field BH acting along north-south. Natural magnetic field, Earth's magnetic field. Due to the flow of current, constant current in the galvanometer copper coil, another magnetic field is produced, which is B. B is given by, just now we have written, mu naught Ni by 2A. The two uniform magnetic fields acting right angles to each other, that's why the suspended magnetic needle comes to rest in the direction of the resultant of two fields, that is theta 30 degree. Meaning tangent galvanometer is working in the first step. That's why deflection is shown 30 degree. If the plane of the coil is rotated through 90 degree, if the plane of the coil is rotated through 90 degree, if this is a plane, this is a plane of the coil, if the coil is rotated through 90 degree like this, if this is the plane of the coil, if the coil is rotated like this, 90 degree, then the magnetic field direction also changes. That means the magnetic field direction comes like this. This is, we cannot change this horizontal magnetic field. Reason, it is naturally available for the Earth. If the plane of the coil is rotated, initially when the plane is like this is the magnetic field. If the plane of the coil is turned through 90 degree, if it is turned through 90 degree, now the magnetic field B becomes like this. Clear? When the plane of the coil is turned by 90 degree, then the magnetic field B becomes parallel to BH. When two magnetic fields are parallel, so tangent galvanometer does not work, meaning whatever may be the current given, the deflection theta is 0, meaning the galvanometer does not work. That is the answer for the problem. But இதே ப்ராப்ளத்தை ஸ்லைட்டாக சேஞ்ச் பண்ணலாம். If the plane of the coil is rotated through 90 degree பதிலாக 180 degree கொடுத்தாங்கன்னா, 90 degree பதிலாக 180 degree கொடுத்துருந்தா, எஸ் இப்படி இருக்கிற plane of the coil just இப்படி ரிவர்ஸ் பண்ணிட்டா, the magnetic field instead of acting in this direction, this magnetic field acts along this direction. 180 degree இருந்தா, at that time the magnetic needle is deflected along this quadrant. So here theta becomes 30 degree again. First 1 and 3 quadrant பதிலாக இப்போ 2 and 4 quadrant deflection வரப்போகுது. So 90 degree deflection turn பண்ணின, the two magnetic fields becoming parallel, the galvanometer does not work. Deflection is 0. 180 degree turn பண்ணின, just the magnetic field is reversed, that's all. So even now the tangent law is applicable, galvanometer works and the deflection shown is same 30 degree, reason the current is also same. That is, if the question is slightly changed, instead of the number 90 degree, 180 degree கொடுத்திருந்தா. So question அப்படியும் கேட்கலாம். Pass on to the next. 41. AB is a rod of lead. The end A is heated. A current I is allowed to flow along AB. Now due to Thomson effect in the rod AB. AB is a rod of lead made by the material lead. The end A is heated. A current I is allowed to flow through AB. Now due to Thomson effect in rod AB. They are asking this, the question number 40. No, 41. Let this one be the rod AB. The rod A is, AB is a rod, it is made by lead, and at the end it is heated. So the heat will be transferred here but lesser amount. So higher temperature, lower temperature. And the current I is allowed to pass along AB. In this direction AB the current is allowed. What happens னு கொடுக்குறாங்க, அது Thomson effect சொல்லியிருக்காங்க. Yes, what is Thomson effect? When electric current is allowed to pass through unequally heated metal rod, the heat is absorbed and also evolved throughout the rod. That is Thomson effect. When current is allowed to pass through unequally heated metal rod, then the heat is absorbed and evolved throughout the rod. That is, the rod is maintained at different temperatures. Say for example, this is one rod AB, let it be copper. When the rod A is heated and the heat is transferred to this point also, meaning higher temperature, lower temperature. When we allow the current in this copper rod, the current is passing from higher temperature to lower temperature. When current is allowed to flow from higher temperature to lower temperature, then the heat is evolved in the rod. This is the Thomson effect exhibited in copper, what we call positive Thomson effect. Not only copper, or even if you allow the current to flow from lower temperature to higher temperature, if you allow the reverse direction of current, lower temperature to higher temperature and current is flowed, then the heat is absorbed, what we call positive Thomson effect. Lower to higher temperature and absorption of heat, higher to lower temperature current flow on evolution of heat. இப்படி இருந்தால் positive Thomson effect. And not only copper, also zinc rod, cadmium rod showing this effect. Similarly, if you consider another rod let it be iron. In this rod also, when end A is heated, thereby the heat is transferred to B. So A is at higher temperature, B is at lower temperature. When we allow the current to flow from A to B, higher temperature to lower temperature, the heat is absorbed in the rod, called negative Thomson effect. Or in other words, when you allow the current from B to A, that means lower temperature to higher temperature, the heat is evolved. This is opposite. When current flows from lower temperature to higher temperature, heat is absorbed. When current is flowing from lower temperature to higher temperature, heat is evolved. That is positive Thomson effect. This is negative Thomson effect. Not only this iron, also platinum, bismuth exhibit this property. இதே மாடலில் leadங்கிற metal rod எடுத்து and A is heated, thereby the heat is transferred to B, higher temperature, lower temperature. When current is allowed to flow from A to B, higher to lower, no absorption of heat, no evolution of heat. When current is allowed to flow from lower temperature to higher temperature, no absorption, no evolution, meaning zero Thomson effect is exhibited by lead. Lead is alone. Lead alone exhibits such property. So, copper, zinc, cadmium exhibit positive Thomson effect. When current flows from lower temperature to higher temperature, heat is absorbed. When current flows from higher temperature to lower temperature, heat is evolved. This iron, platinum, bismuth exhibit negative Thomson effect. That is, when current flows from lower temperature to higher temperature, the heat is evolved. When current flows from higher temperature to lower temperature, the heat is absorbed. Copper opposite negative Thomson effect. When current is flowing from higher temperature to lower temperature, or even lower temperature to higher temperature, no absorption of heat, no evolution of heat, that is in lead. That's why we are using the lead as a third metal in drawing the thermoelectric circuits, thermoelectric diagrams. So to design the thermocouple, we are using the third metal, lead. Reason, lead exhibits zero Thomson effect. So here in this question 41, option C, the heat is neither absorbed nor liberated. No absorption of heat, no evolution of heat, that is option C. Pass on 42. The period of revolution of a charged particle inside a cyclotron does not depend on. அப்போ நம்ம depend on தெரிஞ்சது தான் does not depend on சொல்லலாம். It's always the correct way. The period of revolution of a charged particle inside a cyclotron does not depend on. First, what do you mean by cyclotron? It is the particle accelerator. It is a particle accelerator used to accelerate the charged particle to a high energy, high velocity, for the purpose of nuclear reactions, artificial transmutation. Cyclotron is working on the principle of, yes, a charged particle moving with a velocity, a charged particle moving with a velocity perpendicular to the magnetic field. Lorentz force acts on it, and that Lorentz force is maximum, hence the particle is deflected in circular path. A charged particle moving right angles to magnetic field experiencing a maximum Lorentz force, hence the particle describes circular path. This is the principle of cyclotron. So in cyclotron, in the case of cyclotron, maximum Lorentz force BQV sin theta, theta is 90, sin 90 is 1, so the force is maximum BQV, which is equal to centripetal force. Reason the particle maximum Lorentz force act பண்ணாலே the particle moves in circular path. It is mv square by r, radius of the circular path. So v cancel, hence that v by r is equal to bq by m. But you know, for circular motion, v is equal to r omega, linear velocity, angular velocity relationship, v is equal to r omega. Therefore, v by r is omega. Omega is equal to bq by m, where omega is angular velocity, rate of change of angular displacement. for one circular path, the time taken for one circular path, that is radius vector sweeps 360 degree or say 2 pi radian in a time of t, where t is called time period, a constant for this circular motion always. So 2 pi by t is equal to bq by m. So t is equal to 2 pi m by bq. So அவங்க இதுதான் பேசுகிறாங்க. The period of revolution, இதுதான் period சொல்லாலே constant, periodically repeated, that is already the constant time. So the period of revolution, time period of revolution of a charged particle inside the cyclotron does not depend on, T depends on mass, T depends on B, magnetic field, D depends on charge. So in the equation வராதது எது டிபெண்ட்ஸ்னு 3 டிபெண்ட் வருது, அதில் வராதது எதுன்னா வெலாசிட்டி தான் வரல. ஸோ தட் மஸ்ட் பி த கரெக்ட் ஆப்ஷன் சி, வெலாசிட்டி ஆஃப் த பார்ட்டிகல். ஸோ டைம் பீரியட் இஸ் இண்டிபெண்ட் ஆஃப் த வெலாசிட்டி ஆஃப் த பார்ட்டிகல். Which of the following produces large amount of Joule heating effect? Which of the following produces large amount of Joule heating effect கேட்குறாங்க. Again, that is 1 ampere current through the 2 ohm resistor for 3 seconds. That is I கொடுக்குறாங்க, R கொடுக்குறாங்க, T I square RT ஜூல்ஸில் தான் யூஸ் பண்ண சொல்கிறாங்க. H is equal to I square RT. So in the first case, 1 ampere current through 2 ohm resistor for 3 seconds. 1 ampere current, so H1 is equal to 1 ampere, 1 square into resistance is 2, time is 3. So 3 2s are 6, 6 into 1, 6 joule. H2, second case, that is B, option A. Option B, it is the current is 1 ampere into 3 ohm resistance, 1 square into 3 into 2. Here also it is 6 joule. C, option C, H3 is equal to 2 ampere current, 2 square, and the resistance 3, time is 2. So 2 square 4, 4 3s are 12, 12 2s are 24 joule. And fourth option D, H4 is equal to I square, 3 square 9 into resistance 1 ohm into second is 1. So 9 joule. So it is clear which one is larger. 24 joule is larger. So option C is correct. Which are the following produces large Joule effect கேட்டாங்க. So option C is correct, 24 joule. Using I square RT formula we have to solve this one.